the particular thing about the Quantum Bicycle project was to have a look at the relationship between what electrons made of, what's light made of, how does it work. And where we started was with Martin and myself back in the 90s, is we started with the idea, with the conjecture, and that's what you do with a theory, you just make some stuff up. And then you see how far that gets you, that particular conjecture, and how closely it corresponds with experiment, with what you actually observe. And what we conjectured is, we conjectured that matter was made from light. Now this turns out, in my 2018 view, not to be the whole story, but it is a good part of it. That it's not just made from light, but there's more to it than that. So what we thought back then, and what we conjectured back then, is we thought we knew quite a lot about light, because Martin's an expert in light, and I thought I knew quite a lot about particles, because I was an expert in particles. So what we did is we had a look at the structure of light. And let me just see if we get something here which is perhaps more sensible. This is a picture of the creation event of two electron-positron pair of matter from light, or alternatively, of the destruction event where matter goes into light. So light to matter, or matter to light. So you can read it either in come two photons, these are the photons, the straight lines, and that produces an electron-positron pair. These are these rings just here. Or that the two rings unravel and give you light. You can run it forwards or backwards in time. And both processes happen. So what we did in the first instance is and I'll go back a few slides to this one, because this is going to be a picture of what I'm just going to make here. What we did is we looked at light, and we knew that light contained electric and magnetic fields. It's electromagnetic. And we also know that a circularly polarized photon, that's a photon that has a spin of 1 unit of angular momentum, h bar, has a structure whereby you have an electric field perpendicular to a magnetic field, and that electric and magnetic field spiral through space, each one sweeping up the other one behind it and creating the other one in front of it. So electric changes to magnetic, magnetic changes to electric in a balance, and this balance is described by an equation, and the equation expresses that balance in mathematical terms, whereby the electric field can change, fine, provided it gives you magnetic. And the magnetic field can change, provided it gives you electric. And then having both of those, you have a wave. Waves from one end to the other, from one thing to another thing. And that wave screws through space, spirals through space, producing this wonderful spiraling of electromagnetic field, of the shape of, let's go back to this thing just here. Oops, I didn't know I got that. So you have a spiral coming in, and I'll just make a model of it. So here's a piece of plastic. So we can make a twist in that piece of plastic, which looks like part of a spiral. So, and what the photon looks like from the outside is, it looks like, imagine an electric field poking up on the top of this strip. So if I twist it, then the electric field does a spiral. And you can imagine the magnetic field sticking out sideways just here. And that does a spiral too, but a spiral 90 degrees apart from the electric spiral. So that's what the photon looks like, and that's what the thing, you can measure this. So measure what the electric field distribution looks like in space by sticking a thing in a cavity and just measuring electric field. So that's what they look like, and we've known that for a long time, since Maxwell, which is 1870s. So, so this thing comes in, and what we thought happened, and we still think happens really largely, is the two photons come in, one screwing one way, the other screwing in the same sense but in opposite directions, so they're actually moving in opposite directions with respect to one another. And what they do is they hit each other and they mix. And instead of having an electromagnetic wave going left to right and one going right to left, you now have two oscillations which mix with one another. So one of them goes, so one of them's going leftwards, the other's going rightwards. And what you get is, instead of going left, 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 and right, 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 you get them splitting up into two bits, one which goes right, left, and the other one goes left, right, backwards and forwards, thus confining them and actually changing the shape from being a spiral through space like this to being something which comes back and bites its own tail like this. This motion, so I've taken a twist, a single twist, and I've just turned it around so that something is making it go round, and what you get is naturally is you get this double loop. Now the twist is still in there. If I look at a bit of the double loop, I can still see the twist. But what the twist has done for me is it's made it go zip, zip round twice. If I don't put the twist in and do the same thing, I just get a single loop. But putting the twist in, a whole twist in, and putting it in, I get this double loop. Now this double looping motion of the electromagnetic wave twisting, but as it twists, it also turns. It also turns like this. That twist plus that turn does something spectacular to the electric field of the photon. It means the electric field now, look at it, it's always directed out from the inside. It's outward directed in this case, if we take it sticking up from this strip. So it goes to something which has an electric field sticking out like the spines of a hedgehog, going out in all directions. That's the characteristic of what a charge looks like. A charge has the electric field either sticking out if it's positive, or sticking in if it's negative. That object is charged, and you can calculate that charge. It also spins, spinning round and round, zzz, 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 and it's charged. It's got the electric field sticking out. So what we did back in '97 is we calculated the spin and we calculated the charge. We found the charge was very close to the electron charge, and we found the spin was exactly the spin of the electron. So we identified that thing, and that is this object just here. This double looped thing is this thing just here. Then putting in the fields, pricking outwards, sticking outwards, then you see this is this object just here. You have the same double loop. The green spines are the direction of the electric field, and they're sticking outwards for one of these two things, and they're sticking inwards for the other one. This thing's charge negative, that's charge positive. Net charge going in is 2 uncharged photons. Net charge coming out is +1 -1 is also 0, but in a different configuration, a configuration where the field has become outward facing and hence produced two charged objects, an electron and a positron. So this was Martin and my model back in the 90s of what matter was, what an electron was. And this is the idea, the picture of how electron-positrons create one another. And the paradigm, the model really is, the analogic model of this is that you have a flow of stuff which goes around a double loop like this. And in fact, it's more than that. It goes around a torus, it goes around a donut. So we're going to come into this later. I'll show you where the donut is. But you can actually run a donut through this, and it goes over the surface of a donut-shaped thing. And there are a whole set of nested donuts as well. So this is a toroidal loop, or a loop on a toroidal surface, on a donut-shaped surface. That's very important, and we'll come back to that later. But that's the basic idea of what the quantum bicycle is.